Hi and welcome, I'm Gavin Lon. This is part 2 in a course where we'll create a game using C# and Unity. In part 1 I demonstrated the prototype game, on which the game we are going to create in this course is based. If you haven't yet seen part 1 of this course, please view part 1 at this URL. So, in this video, we are going to install Unity Hub. I'll then show you how you can create a Unity identity for free, which basically involves registering for a free account with Unity, using the relevant registration webpage. We'll then install the latest long-term support release of the Unity editor. The Unity editor is the tool with which we'll create our game. So once we have installed the latest version of the Unity editor, we'll then create a project from within Unity Hub, using Unity's 3D template. Once our new project loads within the Unity editor, we'll explore the default layout presented to us. We'll discuss the various windows displayed to us in the default layout, namely the hierarchy window, the inspector window, the project window, the scene window, and the game window, in order to gain a basic understanding of the Unity windows that we'll mostly use when creating our game. We'll then create a game object for our ground plane in the hierarchy window. We'll subsequently create a game object that will represent our player. I'll demonstrate how you are able to navigate within the scene window, which provides us with a visualization of the game, where we are, as it were, able to navigate the environment that contains the relevant game objects, and customize various visual aspects of our game. If you like this course so far, please hit the like button, and please consider subscribing to the channel. Please ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. I'll play out this video showing a few well-known popular games that have been developed using Unity. Right, let's get started by first installing Unity. Let's navigate to the unity.com website, where we'll firstly download and install Unity Hub. If you already have Unity Hub installed on your PC, of course you can skip this step. In order to download and install Unity, if you're on the Windows platform, the minimum required version of Windows is version 7. You can press the Download for Windows button. Alternatively, you can click Download Other Versions, which links you to a position further down the page where you are able to download Unity for Mac, or follow the instructions for a Linux installation. A little bit further down the page, you are able to review the system requirements for installing Unity Hub on your target computer. So, I have Windows 11 installed on my PC, so I must click the Download for Windows button. Once the install file has downloaded, you can of course simply double-click the relevant file and install Unity Hub. I have already installed Unity Hub, so I'm not going to follow through with this installation. Once you have successfully installed Unity Hub, if you haven't yet created an account with Unity, you can navigate to the appropriate registration page from within Unity Hub by pressing this Create Account menu option. Once you have registered successfully, you can sign into Unity from within Unity Hub. So the next step is to install the latest long-term support release of the Unity editor through Unity Hub. Unity Hub allows us to run multiple versions of the Unity editor side by side. We are going to create our game using the current latest long-term support release of the Unity editor. So let's ensure that we have the latest version of the Unity editor installed. So to do this, let's select this Installs option. You can see here that I've already installed 2 other versions of the Unity editor. So to install the latest version, let's click the Install Editor button. The top option here is the latest LTS release. And we can see here that it is the recommended version of the Unity editor to install. So let's click the Install button to install the relevant version of the Unity editor. So you can at this stage add modules. We are going to use Visual Studio Code as our code editor, which we'll install separately. So if you don't yet have Visual Studio Code installed, you can do that separately. So let's uncheck this checkbox so that we don't install Visual Studio Community 2019. And let's press the Install button. So note, we are installing what's known as Unity Personal. The Pro version of Unity that provides additional features is a paid version. Unity Personal is the free version of Unity. You are able to use Unity Personal to create royalty-free commercial games if you are an individual game developer, a hobbyist, or a small organization with less than $100,000 of revenue or funds raised in the last 12 months. So the installation can take a while, so probably a good time to have a cup of tea or meditate or do something like that while the installation completes. Great, so now that we have installed the latest version of the Unity editor, let's create a new project through Unity Hub. So we have a number of templates upon which we can base our project. But we want to use the 3D template. Let's select a location on our local computers where our project files will reside. And let's name our project OrbJumper. Great, and our project is now created, and we can see displayed to us in the Unity editor the default layout. So here we have the hierarchy window. A sample scene is created by default. Contained within the sample scene are our game objects. We haven't yet created any game objects, but by default we have the main camera here. The main camera captures what's going on in the game. So if we select the main camera, we can see here what the game camera is currently capturing in our scene. Don't confuse what we see in the scene view with what is captured by the main camera. In fact, in the scene view, we can see the camera object, and we are able to adjust the position of the camera in our scene. We can also adjust the position of the camera through a C# script dynamically, which is something we'll do later in this course, where the main camera will be programmed to follow the player game object. We also, by default, have a directional light object present within our hierarchy. Let's navigate to this URL and read what the Unity docs say about the purpose of directional light. Directional lights are very useful for creating effects, such as sunlight, in your scenes. Behaving in many ways like the sun, directional lights can be thought of as distant light sources which exist infinitely far away. A directional light does not have any identifiable source position, and so the light object can be placed anywhere in the scene. All objects in the scene are illuminated as if the light is always from the same direction. The distance of the light from the target object is not defined, and so the light does not diminish. So let's create our first game object. So this game object will serve as the ground plane in our game. You can see here we have a selection of three-dimensional objects that we can add to our scene. So we'll use the Cube GameObject for our ground plane. So let's select Cube from the menu options. Great! So we are able to adjust the position of our cube to the point of origin by resetting the transform settings like this. Right-click the heading of the transform section in the inspector window and select the reset option. So our cube is now at position where x is equal to 0, y is equal to 0, and z is equal to 0. Note that if you ever lose your position in the scene, you can select a particular game object. So, with the cube selected, and make sure the mouse pointer is hovering over the scene window, press the F key. This will immediately make the selected game object the focal point in the scene view. In order to move around the scene view, make sure the hand icon is selected in the top left corner of the screen. You can then press the left mouse button, keep it pressed down, and then appropriately move your mouse to move around the scene, within the scene window. If you want to pivot the scene, as it were, around the selected game object, you can select the relevant object and hold down the Alt key while your left mouse button is also pressed down. And then move the mouse appropriately. So if we select this icon, we can use the handlebars presented to us on the game object to scale the x-axis, the y-axis, or the z-axis, depending on which handlebar is manipulated. We can also use the inspector window to manipulate the scale of the relevant object. So in the transform section of the inspector, let's adjust the scale for the x-axis to 10, and let's adjust the scale of the z-axis to 100. Great, okay, let's add another game object to our scene. This game object will serve as our player. So let's select the Sphere 3D object from the relevant menu, like this. Great, and the sphere-shaped game object has been added to our scene. We can alter its position so that it appears at the point of origin, where the positional x, y, and z values are set to 0. By right-clicking the transform heading here, and then pressing the reset menu option. Great, but we don't want our player game object to stay here. So we can adjust its position through the scene view by selecting the cross arrow icon here. We can then drag the sphere above the ground plane like this, by dragging the green arrow accordingly. So we are adjusting the Y position of the game object. So in the scene window, the x-axis is the horizontal axis, the y-axis is the vertical axis, and the z-axis represents depth, i.e., going into the distance towards the horizon, if you like. We could then scale our orb, or our sphere, by selecting this icon here, but we want our orb to maintain its shape when we scale it. We don't want it to become distorted, so in the inspector, we can link the x, y, and z values by pressing the link icon here in the transform section of the inspector window, adjacent to the scale label. We can then drag any one of these handlebars and scale the orb appropriately. And now the orb is scaled proportionately. So let's manipulate where our orb and our main camera are positioned within our scene view. So if you select the tab that contains the game window, you can see within the window what the main camera is picking up. We can tweak our camera position directly within the scene, as well as using the relevant transform settings until we are satisfied that the main camera is showing a view that includes the sphere and the ground plane, or cube. So note that you can manipulate the X value of the rotation section of the transform section so that the camera lens points downwards towards the cube and the sphere. Play around with the relevant positional settings until you are satisfied that the sphere and the cube appropriately appear in the game view. When we click the play button to play our game, you can see that the Sphere GameObject currently just hovers above the ground plane, but we want to apply real-world physics so that the sphere is subject to the law of gravity. So, how can we do this? In Unity, we can do this by adding an appropriate component to the Sphere GameObject. The component that we need to add to the sphere object is known as the RigidBody Component. We can add a RigidBody component to the Sphere GameObject through the inspector window. To do this, let's click the Add Component button here, then select Physics from the drop-down menu and then select Rigid Body. And we can now see the Rigid Body component is present on the sphere, and the Rigid Body settings are appropriately displayed within the inspector window. One of the settings is named Use Gravity, and is checked by default, so this means by default gravity should affect the sphere. Let's test this by pressing the play button and viewing our game through the game view. Great, and the sphere now falls to the ground as if it were now subject to the law of gravity. The other component that I wish to discuss is the collider component. Each of our game objects have a collider component attached to them. This is why when the sphere falls and eventually collides with the ground, the cube, that the sphere does not simply pass through the ground plane. So these collider components wrap, as it were, around the shape of their respective game objects. The collider components can be used to detect collisions between game objects. We'll see later in this course, we can hook, as it were, through C# code into events that occur when two game objects collide. The C# code will then execute and perform certain custom tasks, like for example, affect the energy level of the player game object. We'll look at this later in the course. If we disable any of the colliders on our game objects like this, when we run the game, you can see the sphere simply passes through the ground plane. This is not what we want. We want to simulate real-world physics, so let's make sure that the relevant colliders are enabled. Great. So in the next part of this course, we'll get our hands dirty and write some C# code to handle player movement. If you haven't yet grasped all of the concepts regarding the Unity editor in this video, don't worry, we'll practice using the various features of the Unity editor as we build the game. My advice is to play around with the Unity editor, for example, add objects to the scene view and manipulate their transform settings, for example, scale and position, and familiarize yourself with moving around the scene view, so that you're more familiar with the Unity editor before the next part of the course is released next week. Let's play this video out with a clip that shows clips for popular games that were developed using Unity. I hope you've enjoyed this part of the course.
Hollow Knight.
If you liked this video, please hit the like button and please consider subscribing to the channel. Please ring the bell so that you'll be notified of future content. Please feel free to share this video with anyone you feel may benefit from its content.
Tarkov.
If you'd like to thank me by buying me a coffee, I've included a link to my Buy Me a Coffee webpage below in the description. It will of course be greatly appreciated. I love reading your comments, so please feel free to engage with me in the comments section. I look forward to seeing you in the next video. Thank you and take care.
Genshin Impact. Fury. Phoenix Point.